time that we left off, I believe all we had was just a snake. That was our square right in the center of the screen, right? So I'm actually pressing up and down and nothing is happening. And that's because, well, we haven't wrote any code for that. So the way that we're going to do this is we are going to put all of the movements inside the snake class, since we want to keep everything that pertains to the snake inside that class, and then as we need to, we'll update it. So instead of writing a whole bunch of things inside this area or even in the main code, we can create methods, or you can think of them like functions, and we can just call each function as we need them, right? So what we're going to do is, it's also easier to help keep it organized, because if you've ever looked at a huge mess of code that's like 200 lines and you're trying to figure out like what does what, it's insane. It's easier to just have everything organized. So we'll create a new method and we'll say, let this be called move snake, or rather, how about snake movements? That sounds better, right? And don't forget to put the self. Okay, we're using a class, and so then we're going to then say this will keep track of the snake's movements. Okay, pretty obvious in the title anyway of this function, but it's all good. All right, so now the way we're going to do this is, let's see, imagine for a second that we have this. Okay, now in this piece, let me see if I can get my pencil here. Here we go. This is our snake that we just made, and this right there, this is our coordinate 300 comma 400. Remember, it was half of the width and then half of the height. Okay, and this is our self dot rect dot x. Okay, and this is our self dot rect dot y. Okay, right in the middle. Now in the screen, okay, there are a couple things. The first thing is that I should really start off by saying this, on a graph, right? If you remember in math class, on a graph, we start here at the origin is where you start, and as you go up, the y values increase, right? This is our y, and this is, as you go to the right, this is our x. Some of the good things is that this is still your y, or your height, and this is still your x. However, the origin is not here in the center, it's actually up here, all the way at the end, at the top left, and this is your 0, 0. Down here in the bottom, okay, so as the numbers, if this is your 0 and you have a height, that means as you go all the way down, your height is going to be down here, 0 comma height, okay, or whatever it is. So in this case, ours was I think it was 800, right? So as you move down, the y values increase. I know that's like, what? Because it's literally the opposite on a graph. As you move to the right though, okay, this actually stays consistent with the regular graph. So this would be 0 comma, or sorry, not 0 comma, this would be your width. Okay, so we've gone a total of 600 units, comma 0. Okay, so this would be 600 comma 0. That's the total width. This is the total height, right? And then down here, of course, would be 600 comma 800, and this will be the absolute farthest that our screen will go. This will be our width, comma our height. Okay, so that might take some getting used to. Also, when we do this, okay, what we're essentially going to want to do is we're going to want to move this a certain amount. So let's say we want to move to the right. That means that we are solely focusing on self.rect. So if this is our self.rect.x, we need to add a certain amount to get to this piece, okay? And we're going to represent that amount by creating another variable, maybe self.snake speed x. Actually, we will use that. Well, yeah, we will use that. Okay, so we're gonna have, this is the location, okay, right now as it is, the initial location, and we're adding a certain amount to get the new location. And the way we're going to represent that then is going to look like this. All right, so we have to create a new attribute here. So self dot snake speed x. Okay, I use underscores to separate spaces. Is equal to 0. Okay, so we'll say this is the initial set initial speed to 0, and then self dot snake underscore speed underscore y equals to 0. Okay, so right now we're not adding anything. It's literally just sitting there. Nothing's moving. The way that we figure out what's happening is, I know down here we did we used pygame.event.get. Rather, what we're going to use is a different method of getting events. So since we want to just focus on the key down events, over here, notice I'm always going to be using this pygame.org. We have pygame.key.getPressed. And this will it creates a list of all of the keys that's pressed, and then from there it returns like Boolean values, like is true, is it false, and it goes through each one and it figures out, okay, well, if this is the one you're looking for, then I'll do this. So what we're going to do is we're going to say for actually we won't say for loop, we'll say key state, okay, and I just named the key state as like the state of the key that's being pressed, right? Pygame dot key dot get pressed, okay, and we're going to say if, now remember this is a list, let me actually write this is a list of the keys that are pressed. So how do you cycle through a list? Remember, it's key state, and then inside of these brackets, okay, if key state, now what specific key? Pygame.k_right. So if the right key is pressed, okay, then we're going to want to move to the right. So we're going to use self.snake speed x is equal to, so this keeps track of our speed. What is our speed? Let's just make it 10. Okay, then we'll do the same thing. If key state of pygame.k_left, okay, then that's going to be self dot speed snake x is equal to -10, right? We're going to be going backwards, and then we could keep on adding from that. If, okay, I'm going to be a little lazy right now, okay, I'm actually going to copy and paste this. If it is going to the right, I'm sorry, now we're going to be going up. Now if we're going up, okay, it's not self.snake speed x, it is going to be self.snake speed y. And if we're going up, okay, remember, the higher you go, the closer to the to 0 is that you're getting to the y. So we're going to be going -10, okay. And if we're going down, okay, then this will be positive, right? We're going towards, the numbers are getting higher towards the height, okay. So this will keep track of all of our buttons being pressed and what to do. Now if we were to run this, nothing's going to happen, okay, because we haven't done anything to the original position, which is this, okay. This is our initial positions. So the way that we do that is we're going to come over here now and we're going to say oh, you know what I just realized? Oh my god, I'm so like, what's going on? So we have a list, right? But how do you cycle through the list? We're gonna have to like literally cycle like through the list. Actually no, we don't have to do that. Let's not do that actually. That might complicate things. So we're going to say self.rect.x plus equals. So we're taking the initial spot as it is right now, and we're adding on self.speed snake speed x. Okay, so this will move the snake right and left. Okay, now if we're going left, right, we're adding on that plus minus. It means I'm adding on a negative value. If you're adding something that's negative, you're still going backwards, right? And then self.rect.y plus equals self.snake speed y. Okay, and this will be doing the snake left and up and down. And if we were to run this, let's just see what would happen. Okay, so I'm gonna go ahead and run this. And what do you notice happens when we run this? Nothing happens. Okay, and that makes sense because we wrote this code inside of a method that we never called. So since we want this to update all the time, we're going to go to our update here and we're going to say self.snake movement, and this calls it every single frame of the second, every time it iterates, right? We're going to be looping around, and let's see now if this works. Okay, so now we have it working perfectly fine. Oh, but did you see that? Hold on. My computer has so much going on right now that I should probably close some programs off. But did you see it go diagonally for a second? Like, that's not what we want at all. So look at this, bam, 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 okay, and then it goes diagonally. That's not good. Okay, so a couple things that we do have to go here is I'm gonna actually put some ellipse here because I feel like that might be more concise. Maybe it's not even necessary, but I like it. And to fix that diagonal thing, it's just that if you're going up, right? So if you're going up, let me make it show this really quickly. 'Cause I know I'm stressed for time here. If you're going up initially, okay, and then you press the right keys, it doesn't just turn right, it actually creates like a vector where our true thing is that we're going to be going diagonally. We don't want that because you can't do that in a snake game. You're not supposed to. So the way that we do that is we need to go back and we need to set, so if we're dealing with the X, we need to set self.snake speed Y back to 0. Okay, so I'm going to copy this, I'm going to paste this here, okay, and then I'm going to paste it down here, but I'm going to change this to the X since the Y is the one that we're talking about, right? And to paste that here. Now, it'll only be adding either to the left, and it's going to keep it. If you're adding 0, right? If you're adding 0, you're going to keep the same line. It's not going to create like that diagonal vector. So if I run this now, right? Might have to do this on a different computer soon, right? You see how we're going to be going up and down, and I realize that when I go to the left, I am not actually going to the left. So I'm going to have to fix that on mine. Let me just make sure that everything is actually fine. So pygame.k_right, lf key state, pygame.k_left, self.snake speed. Oh, that's why. Look at this. Speed snake. Snake speed X. I was wondering why I was not going to the right. Let's see what's up now. Oh, there we go. See, perfect. So now everything looks nice. Now notice that if I go off the screen, it's allowing me to do that. We don't. I mean, I'm not. That's not really supposed to happen, right? So I'm going off the screen, and there's no consequence. So that's what we're going to be doing on our next video. I'm gonna close this off, so at least that works out nicely. And the other thing that I'm going to do now is, you see how I have a 10, 10, 10, 10? If I wanted to change the speed to 5, I would have to go to each one and change them all to 5. Now, this is just for this program. Imagine if you had a much bigger program. What we're going to do is then I'm going to actually create a new variable called just, now I'm not going to call it snake speed X or Y, I'm just going to call it snake speed, okay? And I'm going to give it an initial speed. So here I'm going to copy this, and I'm just going to go and I'm going to replace this wherever I had this. So this was already a 10, which is good. See the negative sign there? I'm going to keep the negative sign, but I'm going to replace it with this. Now the reason why we're doing this is because now if by chance I ever wanted to change the snake speed, I don't need to go to each one. I can change it once here at the beginning, and then it will make all the changes for me. So if I go back and I run this now, it should still run the same. Okay, so here we go. Yep, still running the same, perfectly fine. Okay, and if I want to change it to a 5, make it nice and make it slower. Alright, then you see how much slower it's getting. Okay, it's already making all the changes for us. So I will work on how to do the boundaries next, and because what we want is that once you go off the screen, we want the game to just quit. We don't want to have to like press to quit, right? Okay, sounds good.